Swayam Prabha. Digital India. Educated India.
Okay, so we talk about secure socket layer. This is basically the scheme to provide the security for web based application. Like we have nowadays, we are very much depending on the web based app, e-commerce. So we purchase, if we have a business model, I build a website and I welcome all the people to buy the items through my website, and many things like Facebook, we use the website. So even this Flipkart, so everything. So nowadays we are mostly depending on the website for our online purchase, e-commerce. Okay, so we need to look at the security for this area. So web security. So due to the fact that nearly all business have websites, even it is government or individuals. Okay, so we need to set up the facilities for web for the e-commerce also. Of course, there are major security issues involved here that need to be addressed, because we just access the website without knowing whether it is secure or not. So we need to have the that knowledge should be there. I mean that confidence should be there that the website we are accessing is the secure website. Okay, so as the businesses begin to see the threats of the internet to e-commerce, the demand of the secure web page grows. So this is the topic, is to provide the web security. So there are many approaches are there to providing this web security. So few of the approaches is basically, so we have a TCP/IP stack. So basically IP stack, and then we have a TCP stack protocol in the network protocol. Now various approaches are similar in many ways, but may differ with respect to their scope of applicability and relative location within the TCP/IP protocol stack. For example, we can have security at the IP level, making it transparent to the end user and applications. So inside the IP protocol, IP layer, we can have a security. We can design a security protocol there to give the security for the users and these applications. And another approach could be, which is relatively general purpose solution, is to implement security just above the TCP layer. So we have IP layer, then the TCP layer. So just above the TCP layer, if we can have another layer of security. So that is one example of that is SSL layer. So one example of this approach is the secure socket layer, and which follow on internet standard known as transport layer security. This is a internet standard, TLS. And here we look at the so in this talk we look at the SSL, which was designed by NESCAP. So this is the overview of this SSL protocol or SSL layer. So as mentioned, this is a SSL is a method of providing security for web based applications. It is designed to make use of the TCP to provide the reliable end to end secure service. And SSL is not a single protocol, but rather it has two layers. One is it is basically, SSL is basically on top of the TCP layer, and the SSL is also consist of two layers. One is SSL record protocol and another layer is top layer, and this has four part. We will come to that. 4 part is basically having this SSL handshake protocol, SSL change cyber specification protocol, SSL alert protocol, and HTTP protocol. We will talk about details on this protocol. Okay, so it has basically two layers. So it can be seen that one layer make use of the TCP directly, because this is just on the top of the TCP layer, and this layer is known as SSL record protocol, and it provides basic security services to various higher level protocol. And on top of that, we have basically four protocol. One is this HTTP protocol, and there are 3 more protocol: handshake protocol, change cyber specification protocol, and alert protocol. So, this is just on the top of the SSL record protocol. So, this is the part of this is the top level protocol, top level layer of the SSL. So, SSL have 2 layer, one is SSL record layer, and in the top we have 4 layers. So, these are the 4 protocol in the top layer. So, this is the structure of this is the SSL protocol stack. So, we have a TCP protocol, we have a IP stack, and on top of that so we have a IP stack, we have TCP stack. On top of TCP stack we have this SSL layer. So, SSL layer has two part, it has 2 layers basically. One is it has 2 stack, one is SSL record protocol, that is just on the top of the TCP layer, and another one is the top layer which is having 4 protocol. One is SSL handshake protocol, SSL change cipher specification protocol, SSL alert protocol, and HTTP protocol. So, we will talk about details of these protocols. Okay, so let us talk about SSL record protocol. So, what is the job of SSL record protocol? So, this is basically having two main services provided by this SSL record protocol. One is confidentiality, another one is message integrity. So, confidentiality is usually done by using the conventional encryption primitives, encryption algorithm that use in this service, which is called confidentiality, and we use the message authentication code or MAC for this message integrity. Okay. So, we will talk about this in more details in figure 2. So, what we are doing? So, in order to operate on the data, this protocol perform the following actions. So, it takes the application message, that is the data to be transmitted, and the fragment. So, it is blocks. So, it divides into the fragments, blocks of fixed size, and each block is maximum size is 2 to the power 14. So, basically it is we have a we have the message or the data which to be transmitted, and this data is break into the blocks or the fragments, and each block has size maximum 2 to the power 14 bytes. So, that means 384 bytes or less. So, this is the first step, and then after that each block is then compressed. This is the optional, each block is compressed, which must be lossless, because this compression must not be lossy compression, and may not increase the content length by more than 1024. So, we have a size of 1634. From here we compress, this is optional, compress this to a 1024 bytes. So, this is the compress operation we are doing on the each of this block. So, we have a message which need to be sent this data. So, we break it into the blocks or fragment, and each fragment of size 2 to the power 14 bytes, and then we apply, this is optional, we apply the compression function on this, which must not be lossy compression, this is lossless compression, and we make it into less than 1024 bytes. Now, we just apply the message authentication code or MAC, and then MAC is then computed over the compressed data using the shared secret key. So, and this is then append to the compress block. So, we just break it into the blocks, and then we just compress, and then we have a message. This is a message. Now, this message we apply a MAC, and to apply the MAC, what we can do? We can take some of the bits, say this is some of the bytes we can take. So, this is say 1024 bytes. So, among these we can take some of the bytes, and then we can have the encryption that is using the secret key, and that is the MAC function. So, that we can encrypt using the secret key, and that encrypted on the partial in message is called the MAC, and this MAC value we then append to the plain text at the end. Okay. So, basically we are adding the MAC. So, this the compressed message plus MAC are then encrypted. So, after that we have the compressed message and we append the MAC, and then we have to encrypt this using the symmetric key encryption. The encryption may not increase the content length by more than 1024 bytes. So, that the total length may not exist 2 to the power 14 plus 2048. The number of different encryption algorithm are performed, because this is a symmetric key encryption. So, after appending the MAC on the message, we just apply some encryption algorithm. We can use this is a symmetric key encryption, we can use AES. So, we use the standard encryption technique, because DES we know is breakable. So, we can use AES or some version of AES or triple DES. So, that is the standard encryption algorithm we will use. So, different encryption algorithm are permitted. And final step, we have to prepend the header. So, we got the encrypted that things, and final step we prepend the header. So, this is the general structure. This is the SSL record protocol operation. So, we have given a data or the message which need to be sent. So, this message we break it into the blocks, so that each block will be maximum size 2 to the power 14 bytes. So, these are the fragment. So, each fragments we optionally compress into we apply some compression lossless compression function, and we compress these blocks into maximum 1024 byte, and then we can. So, this is a message. So, we can take some of the bytes, then we apply some encryption algorithm, and we compute this using the secret key. We compute this MAC from this message authentication code, and this MAC we are adding at the end of this compressed message, and then this is the message plus MAC, compressed message plus MAC, and then this we encrypt using the symmetric key encryption. We can use the AES or some triple trace, some non symmetric key encryption, and then after that we need to prepend the header. So, we append the SSL record header. So, the header consists of some field, we will talk about that. So, this is the header. So, this is the operation we are doing by the SSL record protocol. Okay. So, we append the header with this encrypted message. Okay. Now, this is the structure of the header. Header consists of the following field. The first field is content type, which is basically 8 bits. So, we need 8 bit to represent this. So, the higher level protocol used to process the enclosed fragment, and then another 8 bit used to indicate the major version. So, this indicate major version of SSL in use. For example, if the version of the SSL is used SSL v3, then the value of this is 3. So, this 3 will be put in this field, the major version field, and also we use the 8 bits to indicate the minor version. So, if the SSL v3, then the value is 0. So, this 0 will be put in the minor version, and that is also 8 bit, and then the compressed length, which is 16 bit. So, this is the length in byte of the compress or the plain text fragmented. So, this length also you need to maintain in the header. So, header basically consists of this 4 field: content type, which is basically 8 bit, and then the major version, minor version, and the length after compression. So, this 4 information has to be kept in the header. So, total how many? So, total 20. So, 16 plus 8, then plus 16. So, this is the size, this many bits are in the header. So, this we have to prepend in the encrypted message plus MAC. This we have to append here. So, this field, this is the appended the header P appended. So, this field has 4 field like this: content type, major version, minor version, compressed length, length of the compressed message. So, this is the scenario. So, overall format is shown is here. So, this is our message, this is the compressed message, and this compressed message we then compute the MAC, and then this MAC we append with this message, and then after that after adding the MAC we encrypt this using the symmetric key encryption, and then we prepend this type, basically content type. We prepend this header, and header has basically 4 field as we discussed: content type, major version, minor version, and the length of this compressed length. Okay. So, this is the overall structure of the SSL record format, and the content type above is one of the 4 types. The three higher level protocol given above that make use of the SSL record, and 4th known as application data. So, now we talk about the top level. So, after this top level protocols, like we have, so we already, so let us go back to this. So, this we have discussed. Now, let us talk about this top level protocol, like what we are doing here. So, so this is the change ciphertext specification protocol. This consists of a single message which consists of a single byte with the value 1. Okay. This is used to cause the pending state to be copied into the current state, which update the cipher should to be used for this connection. And then the alert protocol, this protocol used to convey the SSL related alert to the pair entry, like it consists of 2 bytes, the first of which takes the value 1, 1 is for warning. So, it will set 1 value 1 if it is warning, and it will set the value 2 if it is fatal. Now, if the label is fatal, then SSL immediately terminate the connection, because there is a danger. So, it is a fatal signal. So, then the SSL. So, this is the alert protocol. Alert protocol use the 2 bytes which takes the value 1 or 2. Okay. So, 1 means just a warning. So, but if it is setting the value 2, then it is a fatal signal. So, if the label is fatal, SSL immediately terminate the connection. Okay. And the second byte contain a code that indicate the specific alert. So, now we talk about the handshaking protocol. This is the most complex part of the SSL and allow the server and the client to authenticate each other. So, this is a authentication part. So, we have this server and client has to authenticate each other by sharing some messages. So, this is a few interaction will be done between them. So, this between the server and the client to authenticate each other, and the negotiate an encryption and the MAC algorithm, and the cryptographic key to be used to protect the data sent in an SSL record. This protocol used before any application data is sent. It consists of series of message exchange by the client and the server. So, we will talk about this. So, how this is happening. So, it has basically, so this is given in figure 5. So, each message has 3 fields. One is the type of the message. So, for this we need 1 byte to represent. So, which indicate the 10 message. So, there are 10 types of message which is shown in the next figure. So, this is the 10 type of message. So, the message type may be hello request, so client hello, then the server hello, certificate, server key exchange, certificate request, server done, certificate verify, client key exchange, finish. So, these are the message type. Now, these are the parameter for hello request. There is no need to have a parameter. For client hello, the version, random, session ID, so which session we are in. So, So, those are the parameters. So, compression method which will to be used, compression method. So, server hello. So, here also version, random or session ID, compression method, and certificate. So, certificate means we should use some standard certificate. So, that is the standard X.504 v3. So, this is chain of X certificate, and then the server key exchange. So, here parameters are basically parameters and the signature, and certificate request basically type, authorities, and server done is no parameter. Server verify is basically the parameter is the signature, and the client key exchange is basically parameter and the signature, and finish is basically the hash value. So, we will have the hash value. So, this is basically 10 message type. So, these are the type of message, and for this we need to have a field which is 1 bit to indicate this one of the type. And then the length is basically 3 byte, length of the message in bytes. So, this is the length consists of, to have the length we use the 3 bytes, and that will store the length of the message in byte. And the content, the parameter associated with the message such as version of the SSL being used. So, this we have seen, and this is the change cipher specification protocol, handshake protocol. So, we have type, length, and content. So, this is the type means one of the type of the message, like we have 10 types. So, this is one of the type. So, to indicate that we use this field, this is one byte, and then we use this field to indicate the length of the message, and this is the message. So, this is the handshaking protocol, and then we have a alert protocol. In the alert protocol we have the label which is used one byte, which is either warning or fatal, and then we have a this is the alert which is used 1 byte, which is either warning or fatal. If it is fatal, then SSL terminate the connection. And then we have a HTTP protocol, which is the other above level protocol. So, which is basically use more than 1 byte. Okay, so, this is there is 4 phase. Let us talk about more details of the handshaking protocol. This has basically 4 phase. This is basically to authenticate between the client and the server. So, this is the to authenticate. So, client will send some message, then server will respond, again client will send. So, these are the in this 4th step, there are 4 steps. In this 4th step, 4 phase, this handshaking protocol will be working. Okay, so, this is establish security capacity. This protocol establish security capacity, including the protocol version, session ID, cipher suit, compression method, and initial random numbers. This phase consists of client hello and server hello message, which contain the following for the client. So, version, the highest SSL version understood by the client, random 32-bit timestamp and 28-bit nonce. These are used as a random numbers, and the session ID, a variable length session identifier. Cyber should list of the cryptographic support by the client to decreasing order of preference. Both key exchange and the cyber specification, this includes fields such as cyber algorithm, MAC algorithm, cyber type, hash size, key material, and IV size. IV we can use for this is IV means initialization vector, and are defined. So, compression method. So, list of the methods supported by the client. And the second phase is server may send certificate, key exchange and request certificate is also signal end of the hello message phase. The certificate send is one of the chain which is used the certificate standard X509. This is the standard of the certificate. So, this standard may be used. Then the server key exchange is sent only if required. A certificate may be requested from the client if needs to be by the certificate request. Okay, so, upon receive, this is the third phase. Upon receiving the, so let us go to the picture. So, this is the phase 1. So, client is sending the hello and the server is responding to hello. This is the phase 1 and this is the phase 2. So, this is the exchange of the certificate. So, certificate is sending server key exchange, certificate request, server hello request, and this is the third phase. So, client is sending the certificate, this is the client side and this is the server side. Phase 2 is the server side and phase 3 is the client side. So, client is sending the certificate in the phase 3, client key exchange, client verify. Okay, client will verify the certificate of the server. Then in the final phase, the change cyber specification and the finish signal is there. So, this is basically the action of the handshaking protocol. So, details description are here in the third space. This is doing by the client, and finally send in the final phase, change cyber specification suit is finished. The secure connection is now set up, and the client server may begin the exchange application layer data, because this is the handshaking protocol is basically used to authenticate each other. So, they are this basically using this 4 phase, they convince that they are authenticated. So, they are communicating with the correct person. So, server is convinced, client is convinced. Now, they will start sending the data. So, thank you.